Good afternoon, students. Welcome back to physics marathon class, and this is after your lunch break. So I hope you people had your lunch and now you people are again energetic to attend the next session. So this is all about the discussion about your AIATS plus, and that happened on 26th of January 2025. So what all topics will be discussing in today's class? So let's understand these topics primarily revolve around ray optics, optical instruments, magnetism and matter, waves, oscillations, wave optics and semiconductor. So these are the topics primarily will be covered in this session of this discussion of your AIATS plus phase 2, and this is your mock test happened on 26th January 2025. So let's start the discussion. Now the very first question says the SHM of a particle is given by the equation x equal to 2 sin omega t plus cos omega t. So let's understand it. Let's split this. So your x is 2 sin omega t. So this individual function sin omega t, this is periodic function as well as your SHM, and the amplitude of this is 2. So this is the individual periodic function and individual SHM. Now let's write down this part. If I say x is equal to cos omega t, this is also periodic and this is your SHM also, but its amplitude is 1. So this is the given information. Now we are talking about the linear combination of these two independent individual SHMs. You can say this is more or less like a superposition of two SHMs also. So now the given question is linear combination of these two functions. So we have to find out the amplitude of oscillation, and we have to find out the amplitude of this complete equation. Now there are two ways. If I say the resultant amplitude if I put it as R only. Now look at this. This is, I'm treating it as linear combination of two SHMs or superposition of two SHMs. So this question we are dealing it in that way only. So its amplitude, let's suppose this is 2. So this is the amplitude 1. So we are putting it as amplitude 1 square. The amplitude of second part we have already discussed it as 1. So this is 1 square plus 2 times amplitude of the first, amplitude of the second, and cos phi, the whole under the root. So this is how we'll define the resultant amplitude of these two SHMs which are combined in this way. Now how you'll look at this cos phi? Cos phi is basically the phase difference between these two functions. So what is the phase difference between these two functions? So sin theta and cos theta, they differ by a phase of pi by 2. So they have a phase difference of pi by 2. So cos phi, this is pi by 2. I hope This much is clear to everyone. Any doubt? Shall we move? So, your resultant amplitude is given to you as 2 square plus 1 square plus 2 times the first amplitude, the second amplitude, and cos phi, that is 90 degree. And this is the whole under the root. What is cos pi by 2? What is cos pi by 2? Cos pi by 2, cos 90 is 0. So this part goes and the resultant amplitude is root of 5. I hope, and this is the easiest of all. So this is the root 5 is the resultant amplitude of this equation, which primarily consists of linear combination of two SHMs. The other way is like x is equal to 2 sine omega t plus cos omega t. What best we can do is 2 square plus, this is again 1, this is 2, 1 square under the root, and we can convert it to a standard equation of SHM also, like, so we'll divide it by the same expression. And you know, if you consider this part, this much, this part as cos phi, so this is root 5, we can put it as sine omega t cos phi, plus if you consider this part as sine phi cos omega t sine phi, and when you look at it, this is root 5 sine A cos B cos A sine B. So that gives you a standard expression as this one. So if you look at this, this is also a standard equation of SHM, and this is the amplitude of the resultant equation. So these are the two ways by which you can solve this question. Either you convert the given equation into a standardized SHM, that will also give you the amplitude, or you can simply put it that way. So these are the two best ways to understand this concept. Any doubt from this part? Anything else from this part? So I think we should move on. Okay. Now, phase difference, the next question is from the SHM part again. The phase difference in radians between displacement and velocity in SHM. So this is also quite interesting. So here again we are dealing SHM. So let's understand with the help of an example. So this is your mean position, and these are the two extreme positions we have. So at time t equal to 0, if particle starts executing this SHM from its mean position when time is 0, so the standard equation for its displacement is given by this expression. So this is the standardized equation. So please pay attention when particle is at its mean position. So at time t equal to 0, if particle is starting its SHM, or you have observed your SHM at time t equal to 0, so its displacement is given by this expression, x equal to a sine omega t, where a is this part, that is called its amplitude. So this is the standardized equation. Now this is the equation that represents the expression for the displacement of the particle. Now we can understand how the velocity can be defined from this displacement equation. So to define the velocity, we'll simply differentiate this expression with respect to t, and that defines the velocity v. And when you differentiate, a being a constant will remain there. The derivative of sine, that becomes cos, so this is cos omega t. It involves chain rule, so derivative of d by dt of omega t, that gives you another omega. So this is the expression for its velocity. So if I call this as my displacement amplitude, so this is the maximum velocity of, this is the maximum value of the velocity, we call it as the maximum amplitude for the velocity expression also. Now we have to find out the phase difference. So how do you find out the phase difference? So look at this, the phase difference, so this is sine and this is cos. So if you look at the graph also of these two, so if I say x with respect to t, so for the displacement part, this is how the graph looks like. And if you draw the velocity time graph for the same, this is how the velocity looks like. So just by looking at or just by comparing their graphs, we can well find out the answer. The answer between these two, the phase difference between these two is 90 degree, that is pi by 2 radians, because we have to answer it in terms of radians. So probably your answer is pi by 2 only. So we have the answer. Now we have a question from one of the viewer, and question is, sir, if your particle starts its SHM from the extreme position, then what would be the answer for this? So this is a very fine question. So let's suppose at time t equal to 0, particle is at its extreme position, that is starting its SHM from the amplitude end, from its extreme position. So its displacement equation, this is where these two are slightly different. How they are different? Just by looking at this expression. Now the displacement equation is given by x equal to a cos omega t. So instead of sine, look at this. Here the expression was in terms of sine when particle was starting its position from the mean position, when particle was starting actually its SHM from the mean position. But now this time particle is starting from its extreme position. So see the difference in the displacement. And again, to define the velocity, we'll again differentiate it. That defines the velocity, and a being constant, again the amplitude, so that remains constant. Derivative of cos is minus sine, so shall I put it as minus sine omega t, and d by dt of this omega t again gives you omega. So this is the expression for the velocity of the particle executing SHM, and particle has started its SHM from extreme position. Now again you look at these two functions. So one is sine function, one is cos function. So whenever you have sine theta and cos theta, so they have a standard phase difference of 90 degree, that is pi by 2. So your phase difference between the displacement and its velocity would again be what? Pi by 2 radians. I hope you people have understood this concept, and I can guarantee you with this small understanding, you people are going to get all the questions correct in your NEET 2025, at least from this part or this section. So any doubt from this part? or shall we move? Fine. So let's move further. Now the next question is again from a altogether different area, and this deals with magnetic materials having negative magnetic susceptibility. So this is about magnetic materials and this is about magnetic susceptibility. So let's briefly build up the concept of susceptibility. So if I give you a magnetic material, so this is one type of magnetic material, this is another type of magnetic material, and we have another type of magnetic material. All these three are of three different types, and let's suppose we apply some field, and this H is basically the magnetizing field we have. You got it or not? We can understand all the individual magnetic dipoles within this material. They are randomly oriented initially, but the moment you apply some external magnetizing field H to this type of material, the resultant dipole moment is something like this. And in this situation, the resultant dipole moment is something like this, and in this situation, resultant dipole moment is something like this. Now, this type of material is basically your diamagnetic type. This type is your paramagnetic type. And the last one is basically the ferromagnetic type. So, first of all, this is ferromagnetic. We need to understand what do you mean by susceptibility. So here we are talking about magnetic susceptibility. So for this magnetic susceptibility, we write down it with the symbol that is chi m. And you know, the basic standard definition of it, this is defined as I by H, where I is called magnetic moment. This is the resultant magnetic moment developed per unit volume of the magnetic material. So by H we have understood it as magnetizing field. So just by looking, so this is a standard definition. Just by looking at the diagram, H, can you see the direction of H? So when we say the resultant magnetic moment developed per unit volume, that is called intensity of magnetization also. So I is also defined as or understood as intensity of magnetization. Now look at this. So here the intensity of magnetization is weak, and that is opposite to H. So it means if you look at chi m, the value of chi m in terms of direction, so this I and H are opposite, so this chi m is negative for diamagnetic. Here I and H, they are in the pointing in the same direction, so chi m is positive, and here this is strongly magnetized, so chi m is also positive because I, that is intensity of magnetization, that is also in the direction of H. So this is all about the basics of your magnetic materials. So we have magnetic materials. So we have tried to answer, we have tried to understand the basic three types: diamagnetic, paramagnetic, and ferromagnetic. So these are the three basic magnetic materials we have in the nature. Now the question was, magnetic susceptibility is negative for, and I think with this explanation, with this understanding, we have understood it very clearly. Chi m is negative for which type of magnetic material? Yes, this is diamagnetic. So I hope we have tried to build up the concept around surrounding the same question, and based on that concept we have got the answer for this very easily. So this is the power of concepts. If you understand your concepts, if you build up your concepts well, then these questions are quite easy and interesting for you. I hope if you are clear on this part, please allow me to move forward. Shall we? Fine. Now, the next question is also from a very interesting area, and this is one of the important areas. It deals with your electromagnetic waves. So what your question says? The phase difference. So today we have a very important day because most of the questions, they revolve around, in at least particularly in this part of physics. So we are talking about phase difference. So basically phase basically defines the relative vibration state of a particle. So again we have a different variety, and that deals with the phase or phase difference between electric field and magnetic field in a traveling electromagnetic wave. So I would like to build up a bit of information about your electromagnetic wave that basically helps you to understand the EM wave, and you'll be able to answer varieties of questions based on the same concept. So electromagnetic wave, and this is also known as EM wave. So in short, we can call it as EM wave also. So electromagnetic wave. So what is the basic nature of this? What is the basic nature? This is transverse in nature. So this is transverse in nature. What do you mean by transverse wave? I think we have been dealing with this word since our 7th, 8th, 9th class concepts. So let's understand and how this electromagnetic wave seems to be. So let's suppose we define this axis as x-axis and this is your y-axis. Now if I draw your transverse wave, can you see this transverse wave? So transverse wave in which particles of the medium, they vibrate in a direction perpendicular to the velocity or the propagation. So it means your wave is assumed to be propagating along this x-axis. So your particles, they are vibrating along y or maybe along z-axis, because that is the basic word, basic definition of your transverse. So we have vibration state, and these vibration states may be along y or may be along z-axis. So this is, you are defining it as z-axis. Now, so this is basically a transverse wave. Now the next word is electromagnetic wave. It means transverse traveling wave. This is a transverse traveling wave. And let's suppose if I write down a general equation for a traveling wave, and that is propagating or traveling along positive x-axis. So the general equation for traveling wave is given to you as y is equal to a sine omega t minus kx, where a is the amplitude, k, which is very important, this is called propagation constant, and this propagation constant k can be written as 2 pi by lambda, where lambda is the wavelength of this wave, and omega we all understand it as. So what is the speed of the wave? So speed of the wave is given to you as omega by k. Do we understand? And how we write down omega? Omega is 2 pi by t, and this is 2 pi by lambda. So that means lambda by t, or lambda times frequency, and that is the speed of the wave. This is basically the amplitude of this traveling wave. So we have understood the basic transverse nature, the equation of the traveling wave, and this is how the equation for a traveling wave which is traveling along positive x-axis. So point to be noted, here it is traveling along x-axis, and this negative sign indicates it is traveling towards positive x-axis. This much is clear to everyone. Now, so this is, like, function which is basically dependent on position as well as time, and that suggests it's a traveling wave. Now when we say electromagnetic, it means electric field, time varying electric field and time varying magnetic field, both are associated with the wave simultaneously. So if I assume my electric field is, let's suppose, along y-axis, then possibly I can say my magnetic field is along z-axis, or it can be vice versa also. But we have to be very particular while defining it. Reason being, we have to satisfy one more condition, and that condition is to do with this expression. The velocity of wave is given by E cross B. So we need to satisfy this equation also while defining the electric field and magnetic field. Now for the same electric field, we can write down as E naught sine, because wave is traveling along positive x-axis as per our assumption. So this is omega t minus kx, where E naught is the amplitude of the electric field vector. Then magnetic field is B naught sine omega t minus kx. Now if this is along, we have to satisfy this expression. So we'll simply put it like this. So this is I. So simply if I put it as j cross k, so j cross k is your I vector. So this is j, it means I am talking about its y component, and if it is z, so I am talking about the k component. So this is one expression which is really helpful for you, and second one is it also satisfies this relation for this EM wave, the ratio of these two amplitudes, E naught by B naught, and that is constant, which is as speed of light. So which is, everybody is aware of it, it is 3 into 10 raised to power 8 meters per second. So this is something there to understand the EM wave, its basic nature and other things. Now the question is phase difference. So look at this. This is sine and this is sine. So both the waves, they are represented by the same sine function traveling in the same direction, and they have different components. So electric field and magnetic field are perpendicular to each other as well as perpendicular to the velocity or the direction of propagation. But as far as these two waves, this wave and this wave is concerned, so what is your call on this as far as phase difference is concerned between electric field and magnetic field? Look at this very carefully. This is sine, this is sine. So what is your call on it? This is phase difference is 0. So I hope everyone has understood this part also. So this phase difference is 0, and I have even tried to build up the concept around the same question, and all these small inputs from our side will help you to not only attempt this kind of question, but the questions which can be asked surrounding all these properties also. So any doubt from this part? Shall we move? Fine. Now the next question is again quite interesting. In a Young's double slit experiment, the intensity at a point where your path difference is lambda by 4 is I. If I naught denotes the maximum resultant intensity, then I is equal to I by I naught is equal to. So this is your question. Now first of all, let's suppose we have this is basically again interference of two waves. So we have a first wave whose intensity is I1. We have a second wave whose intensity is I2, and they have a phase difference phi. So your resultant intensity, I am writing it as IR, which is I1 square plus I2 square plus 2 I1 I2 cos phi under the root. So this is the general expression again as far as the interference of these two waves from the YDSC. Now primarily if you talk about Young's double slit experiment YDSC, so we always talk about coherent sources. So we have coherent sources, and for the coherent sources intensity of these two, let's suppose we assume it as I naught. Got it? So what it becomes? I naught cos phi. This is I naught square and this is your resultant intensity is. So this goes something like this. And this part we can write it down as 2 cos square phi by 2. So resultant intensity can also be written as you got it or not? So this is I make one correction because we are talking about intensity. So in intensity part we don't need to put a square root sign there. That is to do with the amplitude part. So this is the resultant intensity. So this resultant intensity is the expression. Now this is the maximum intensity we have. So this maximum intensity itself is given to you as per your question. If I naught denotes the maximum resultant intensity, so this 4 I naught is given to you as the resultant intensity. So this is how the expression looks like. So this is the expression we were looking for as per the given statement. Now what is this phi? Phi is phase difference. Again, so today we are lucky to have all these questions revolving around the same common word, phase difference. So how you will find out the phase difference? Do we have a phase difference in the question? No. So what is given to you as, this is what? Path difference. So the resultant intensity is given to you as I, where path difference is lambda by 4. So this is I, this is maximum intensity. Now we have one more expression. This expression will help you. I am writing it down. 2 pi by lambda into path difference is equal to your phase difference. Now path difference in the given problem is given to you as lambda by 4. Do we understand? So this lambda goes with this, and that gives you probable as pi by 2. So this is pi by 2. But here we have to take pi by 2 or 5 by 2. So that makes it what? So this is 90. So that makes it pi by 4. And in the given situation, we have to find out the ratio of this one, which is equal to cos square pi by 4. And we understand cos pi by 4, that is 45 degree, is what? 1 by root 2. And when you take the square of this, so that becomes 1 by 2. And this is the required answer for this problem. So just look at the path, how we have built up the concept and how we have reached the answer. So just by looking at the process, so this process of concept building will help you not to understand and solve this problem, but will help you to understand and solve varieties of other problems also revolving around the same concept. So this is the beauty of physics. If you understand the concept well, you can attempt all the questions within ease. So let's move to the next question. And next question is also interesting. The angle of prism is 6 degree and its refractive index is 1.5. If a light ray passes through it, then deviation produced by prism will be. So this is a question from your prism part. So let's understand your prism. So this is your prism and this is primarily your angle of prism, or sometimes we call it as a refracting angle also. So this is the original direction of incident ray and this is the normal. So this is your angle of incidence. Can you see this as your refracted ray, and I am labeling this point, this angle as R1, that is angle of refraction, and it hits at the second normal N. I think we can understand it, no need to write. And final emergent ray is something like this. So I call this as my angle of emergence, and this is your second angle R2. And you know, if you plot it, if you plot this one backward, a bit of backward, so what you will observe, this is your angle of deviation. So can you see the angle of deviation? Yes, so this is angle of deviation. Now, as per your equation of prism, A plus delta is I plus E. So this is one part. So I think we all can understand this part. Yes. So this was the situation. Now, let's continue. So we were discussing about the angle of equation of prism, and that was I plus E is equal to A plus delta. And you know, for minimum deviation, refractive index for minimum deviation is given to you as sine A plus delta m by 2 by sine A by 2. So this is also important. Now, for very small angles, we know sine theta can be substituted as sine theta can be substituted as theta only. So this expression will get reduced to what? This expression will get reduced to A plus delta m by 2 by A by 2. So this 2 goes with this. So your mu seems to be A plus delta m by A. And when you rearrange it, it gives you delta m as A mu minus 1. So this is the required expression actually we are looking for. Now, your question says, if angle of prism is 6 degree, which is a very small angle, so angle of prism is A, so I think we can write it down as 6 degree. Refractive index is 1.5, so this 1.5 minus 1 will give you 0.5, multiply by this, so that gives you 3 degree. And this is what they are looking for, deviation produced by the prism, and that is 3 degree. So this is for this part, deviation produced by the prism, and that would be 3 degree. So I hope we are clear on this. Anything else? Shall we move? Shall we move? So shall we move on? Fine. So what's the next question? Function of rectifier. So what is this rectifier is? So rectifier is, if I simply go by the definition, that basically is an electrical device, or you can say to the extent as electronic device also, which can convert your AC to DC, and this is principally based on biasing of your diodes. So this is a very simple question, function of rectifier. So we can cover the discussion of this part also, but as the time does not allow much to discuss in detail, so we'll pick up the answer for this. So this is the function of rectifier is to convert AC into DC. So this is the simple question we have. So I think we should move on. Yes, this is the question which is again from a different area that deals with your optical instruments. So this question is, in UV method, to find the focal length of convex lens. So here we are talking about convex lens. When an object is at a distance 20 centimeter. So this is one position, first position of your object, and 10 centimeter. So this is probably the second position of the same object for the same lens from a lens. A real image and a virtual image is formed respectively, having same magnification. The focal length of the lens is. Now we have to find out the focal length. So first of all, I would like to highlight the concept of magnification. So this magnification is written as M, and we simply say this is size of image by size of object. So usually your objects are placed upright erect above the principal axis. So this is upright erect. So object, it is upright erect. And if your image is inverted, so I think we can understand all the distances or measurements are from the principal axis, that is your reference axis. So if it is upward, so that is positive, and if it is downwards below the principal axis, so that would be negative. So in that situation, magnification will have a sign convention as negative. And if object and image both are upright erect, so your magnification will have a positive sign convention also. So your magnification can be positive as well as negative. So this is one part. And you know, for a convex lens, if you remember your detailed ray diagrams for all the possible cases, so in one situation when you have object and its image both are upright erect, so that is the situation that we deal in simple microscope also, when you place your object between focus and the optical center. So that defines a virtual erect image. So that defines magnification as positive, and in rest of the other cases magnification is negative. So that would give you real and the inverted image. So this is something which I have added to understand. Now, so we need to understand this and how this magnification is related to your focal length and object distance u. and that is given to you as m is equal to f upon f plus u. If time permits, then I would have given you the definition and the complete explanation of this concept also, how we are getting this expression for the magnification. But for this situation, let's understand the formula, let's understand the concept from this base area. So in one situation, magnification is positive, and let's place this situation as for first position of your object maybe as u. For the second situation, when you have object placed at a different position u2, but in one situation you have a real image, and in the real image formed would be inverted, so that would give you the -1. So this is your first expression, this is your second expression, and if I say this is your, let's suppose, negative magnification, numerically both go same, but how they are different? Because of the nature concept. So when you equate these two expressions, I am not solving the algebraical format for this, but your focal length comes out to be this one. And this is what we are looking for actually. So now we have two positions, 20 centimeter and 10 centimeter. So first 20, for the second one 10, and that gives you 15 centimeter as your focal length for this situation, and your answer will goes with the third option. So I hope you have understood this concept also. So we should move on. Yes, the next question is again from the optics. An object is placed at a distance of 30 centimeter. So this is the very first data says. So let's take this as with the sign convention 30 centimeter. From the pole of a convex mirror, radius of curvature of the mirror is 60 centimeter. Now the best part is focal length of mirror is r by 2, that is radius of curvature by 2. And for a convex mirror, its focal length is positive, so this is also positive, and 60 by 2, that gives us 30 centimeters. So that is another value given to us. Now, image will be formed at, all the distances are measured from the reference, and reference is your pole. So for this, what is your mirror equation is 1 by u plus 1 by v is equal to 1 by f. Now we have to find out position of the image. So simply they are asking us to solve the value for v. So this is, we have to find it out. So this is 1 by 30 and this is positive, and I am taking this 1 by u on the other side with again the sign convention as this one minus 30, and when you solve it, it gives you the numerical value of v, that is the position of the image as 15 centimeter, and this is again from the pole itself. So I hope we have understood this part also. Shall we move? Fine. So let's move further. Yes, in Young's interference experiment, two slits are illuminated with orange light of wavelength 6000 angstroms. The interference pattern is observed on screen far from slit planes. If the central bright fringe is numbered as 0, what must be the path difference for light from two slits at fourth bright fringe? This is quite easy, though we can discuss the detailed concept, but time doesn't allow you to discuss much about this part. So let's come to the direct path difference. And we are talking about bright fringe. Bright fringe means we are discussing or we are oriented towards your constructive interference, and that path difference for the constructive interference is given to you as n lambda. I think this is the condition, everybody is aware of it. So here we are talking about the fourth bright fringe. So simply put this n as fourth. This is for the fourth bright fringe, and 4 times lambda. So this lambda is 6000 angstroms. So that gives you 24,000 into 10 to the power minus 10 meters. But I think we have, look at the options, that is in micro. Micro stand for 10 to the power minus 6. So you just take out this, and that is 2.4 micrometer. So this is the simplest of all. How we have to find out the path difference for the fourth bright fringe. I hope everyone has understood this part also. Shall we? Fine. Now, a PN photodiode is fabricated from semiconductor material with a band gap of 2.5 electron volt. The photodiode can detect the light of wavelength. So first you try to understand what is this band gap. Band gap is basically the energy difference between these two energy levels. So this energy difference is given to you as 2.5 electron volt. If I convert this to your SI system, so this is probably in joules. And we know energy is given to you as hc by lambda, where h is your Planck's constant, 6.64 into 10 to the power minus 34, and c being the speed of light as 3 into 10 to the power 8. Because in this expression we have to detect a light of a particular wavelength, that means we have to define the wavelength. So we'll take this energy part on the other side in the denominator. For these kind of question, what is important is the unit convergence. So we have to standardize all the values in SI system, and when you solve it, this probably, this wavelength comes out to be 4960 angstroms. When you solve this expression, it means your diode can detect all the possible wavelengths which are smaller than this value. So can you detect this one? Not at all. Not at all. And when you convert this, so this is also 45,000 angstrom. So this is also not possible. 4960, but this is smaller than 4960. So we can identify this one very easily. So that was all about that question. Anything? Any doubt? So let's move. The graph between square of time period and length of simple pendulum. Very simple question. Everybody is aware of the time period of simple pendulum as 2 pi root L by G. So square of the time period, so let's square both the sides. And when you look at this, t square, this being a constant, is directly proportional to L. So they are asking us to find out the graph between t square and L only, and that seems to be a straight line. I hope this is also one of the easiest questions we have. We should move on. Equation of a progressive wave is given by this one. And this is the same situation we had in the EM wave. So this is a traveling wave. So I will not take much of the time. Your traveling wave is 0.4 sine 314t minus 3.14 x. And you know, when you compare it with a standardized traveling equation that I gave it to you in the previous example also. So this is the situation. We have to find out the speed of the wave. I think in that expression only I made it clear. Speed of the expression is omega by k. And just by looking at the expression, what is this omega? Omega is 314. Can you find out k just by comparing? Yes, 3.14, and that is 100. So x is in meter, t is in second, so this probably will have the units 100 meter per second, and this is the expression we are looking for. So this is all about for today's physics part. I hope I have made to understand you all the concepts briefly and well. So this is again Puneet Kathuria, your physics faculty from Aakash Institute. So any doubt, you can always contact us. And for the time being, thank you very much. Thanks for attending this session. Thank you.